Okay, let's begin. So all of you, can you see this interface? You have sent me in. Okay. And do you want me to look at that Excel sheet? What does it have? It has data. It has questions. What does it have? Okay. So let me then download that first. Okay, so let's bring that data that we just got and see how does it work. Okay, so it's a big file, Usman. I have a student version. I won't be able to import that. Let's do a few examples with the data set that I have, and then we can check your data set, because it has more than 1,500 variables and more than 1,500 data points and more than 50 variables, any of these, and that's why this student version is not able to open it. Okay? Is it okay with you? Okay. So let's go with this data set, do some analysis, and then we'll check the other data set. So this is the speed data set that we have been using. The first thing is that we conduct the correlation analysis, which is here, which says correlate. Now bivariate is actually, it's mostly for the group control data. It's for the data where we have one as the independent variables and others as the group. That is what we usually use in case of most of the quantitative data that we do. What we use is a partial correlation, and in that, or I was wrong, maybe it was the other way around, but yes. The partial is the one that we usually use for when one is control and the other is the independent variable. So in case, let's enter all these: postage speed and lane width and median width and axis density and segment length. Here, then we want to conduct a two-tail test. You know the difference between the two-tail and the one-tail test. No display? Yeah, slides are not visible because I have closed the slides. Why do we want to see the slides? The slides are not there. I want to SPSS is also not okay. Is it visible now? Okay. So I have brought in this data, and we go to then analyze, and then we pick this bivariate. And then we enter, let's say we want to find out the correlation analysis. We want to conduct the correlation analysis between all variables. So here. And then what we have here Pearson, Kendalls, and Spearman. These are the different statisticians that develop different methodology. For the quantitative data that we have, the kind of the data that we have, we usually conduct, yes. Do you have a question? Yes, you can use less variables. If you don't want to, you can take out these variables. Let's see, you take that out. So it's up to you. The first attempt that we usually do is that we select all the variables, and then we see which variables are significant and which variables are not significant. So you may want to include all the variables. Without including them, you would not know whether those variables are significantly correlated with your dependent variable or not. So let's select all of them. Or maybe you start with all of them, then when you see that they are not highly correlated, then in your final table or in your final correlation, like the table that you create, you don't show all of them. You just show the ones that are highly significantly have the significant relationship with your independent variable. So Pearson is the one that we usually use for the continuous data. Kendall-Tolles is the one that we use when we have the categorical data or when we have the groups within our data sets. So we'll use the Pearson, and then let's see what do we have an option here. It says that do we also want to see the mean and the standard deviation? Well, let's not see it here now. Let's continue without seeing that. And then let's see, what does it have? So it gave us a table here that shows us, which is similar to the one that we saw in our slides. It's the speed data. This is the independent data, and then the first row shows the correlation between the dependent variable and all the independent variables here. You see here that the sigma values, let's say that the two-tailed sigma value, whether this correlation is significant or not. So this posted speed limit is significant. This is significant. What is showing here 0.508 is that this 0.508 is greater than 0.05. So it's not even the value of R over here is very weak. The significance value tells us that this is not significantly explaining it's not significantly related with our dependent variable, so we may take this out. Now let's read this. 0.729 is the value of R, or the correlation coefficient, and which means it's closer to 1. It is highly correlated with the speeds of the vehicle. The posted speed is highly correlated with the speeds of the vehicles, and it has a positive relationship. So as we post the higher speed limits, the speeds of the vehicle will increase. Lane width has it's a kind of a weak relationship, but it's still positive. Median width does not have any significant relationship with this speed. So median, in this case, in the set of the data that we have here, it's showing that the medians are not affecting the speeds of the vehicles on our roadways. Again, access density here, it's showing a positive value here, which is kind of very counterintuitive, because as the number of driveways increase, the speeds of the vehicle decrease here. That again gives a flag here that maybe the excess density data that we collected, or the way we interpreted it, or the way we coded it in our data set is not correct, because this is totally counterintuitive. As you increase the number of shops along your roadway, as you increase the number of houses along your roadway, which means the excesses are increasing, there will be more interaction. People will see more parking, or you'll see more pedestrians. There will be more disruptions, which means less speed. So there is something wrong with the excess density here. So it's better that we either should take it out, we not use it in our regression model. Segment length here, again, it is the segment length, or the length of the roadway without signals. The longer the roadway without signals, the higher the speed will be, and it shows a significant relationship. So we saw that only speed limit and segment length are highly correlated. Others are okay, but let's see, we'll still keep lane width in our regression model, and we see how does it. Or let's keep all of them for now and then interpret and see how does it affect. So we go to analyze again, and then we do the regression. See here the linear regression and the curve estimation. We'll do the linear regression, but let's see what does it have in curve estimation. So see, it has a linear, it has quadratic, compound, growth, exponential. You can try all of these and see which one gives you a strong model, but the simplest one is the linear regression model. So we go here, we won't discuss this ordinal here. Ordinal is something which is logistic regression model, which is something which is kind of a very at an advanced level. So we select the linear. In this window comes up. Dependent variable is the speed data. Posted speed is the independent variable. Lane width. Were we giving the lane width? Yes. See, it won't let me select median type. It says string variables are not allowed in the list, which means that this linear regression model, this particular type of model, does not let us use a categorical. Median type is a categorical variable here, and SPSS won't let us select it, because in linear model we can still have the categorical variable, but this particular model that we are using here does not take the categorical variable or the qualitative variable, and for that we may have to use some other models. So I will use that, but first we will have to reduce that data. Let's finish this and then we'll use that, because it has more variables. Okay, and then let's say median width. Let's take all of them now. Excess density, and then the segment length. You see here the method, which means, see, we can conduct the regression analysis, the simple linear regression analysis, using different methods. Enter means you enter all the variables, and then you interpret the model, and then depending on which one, like the values of P and all those, then you take out the variables out of it. Stepwise is a regression technique in which what the SPSS or the software does it takes one variable only, and then it takes another variable, and then sees the strength of the relationship. If the strength is not good, then it takes another variable. It's kind of a step. It takes independent variables, it takes out independent variables from the model until and unless it finds the best model that the software thinks it's good based on the data that you have. And then we have remove, and then we have backward and forward. Backward and forward are something is that first it selects all the independent variables, it checks the model, and then it starts taking out the variables which are not important or which are not significant. And forward is the just opposite of backward. It selects one at a time and keeps adding the variables and gives